Hello, everybody. Welcome back. We're talking about exponents and scientific notation. Scientific notation. I got to remember to show you guys that national debt clock too when we talk about this, okay? So, guys, we are going to be simplifying exponents. And so, when we're simplifying exponents, guys, I think I want to use a different color. Hold on a second. I am going to use a different color because I don't like this color the way it's turning out. Okay, we're simplifying exponents, guys. Exponents, what do they show? Exponents show repeated multiplication. That's what exponents show. So, given, let's say, 3x to the second power, guys, I'm giving you some vocabulary. The 3, the coefficient, this 3 right here is referred to as the coefficient, the coefficient. You know I love it when you guys use the terminology, so please use the terminology, the coefficient. Now, the x right here represents the base. And then last but not least, this represents the power or the exponent. So you need to know these terms, okay? So now, guys, that you know these terms, let's move on to the rules of exponents. Rule number 1, the most basic rule, is the product rule. By the way, as you move on further into the mathematics spectrum, you will see the product rule over and over again, guys, okay? The product rule states this: if you are multiplying with the same base, if you multiply with the same base, in this case, the base is A, you keep the base A, and you add the powers or the exponents together. So once again, if you're multiplying with the same base, you keep the base and you add the powers together. So in other words, multiplication becomes addition, okay? Keep that in mind, guys. Keep it in the back of your mind somewhere. You will see this again. So here's a quick example, guys. So let's say you have x to the third times x to the second times x. By the way, when you have a base with no power, the power is understood to be 1. There is a power there. You just can't see it, okay? So what you do is you keep the base x and then add the powers on the x's. 3 plus 2 plus 1. That's going to give you 6. That's the same thing as just counting it out, guys. You have 3 x's plus 2 more plus 1 more altogether. How many x's do you have? You have 6 of them. That makes sense, doesn't it? Okay, here's another quick one. 4x to the third times 5x to the second. So you multiply the 4 and the 5 together. That's going to give you 20. Now, if you multiply x cubed times x squared, you're going to keep the base x and then add the powers together. So that's going to give you 20x to the fifth, guys. Okay? Very easy and to the point. So that's rule number 1. The product rule says when you multiply with the same base, keep the base, add the powers. Next, guys, the quotient rule. Now for the quotient, by the way, quotient means division. It says if you're dividing with the same base, you keep the base, in this case A, and you subtract the exponents or the powers, okay? So, in other words, division becomes subtraction. Keep this in the back of your head somewhere, guys. So essentially, if we were to be given a problem such as this one right here, z to the 8th power over z to the 3rd power, we would keep the base z and subtract the powers on the z's, okay? Subtract 8 and 3 together, and so this would leave us with z to the 5th power. Likewise, guys, if we have 3 to the 9th power over 3 to the 3rd power, we'd keep the base 3 subtract the powers together, 9 minus 3. So that would leave us with 3 to the 6th power. And on your calculators, you can type this on your calculator. So you would hit 3, hit your power key. The power key is also referred to as the delta or the caret, and then 3, guys, and then work it out, and that will give you the answer to this. 27 times 27. What's 27 times 27? I think it's 343. Don't quote me on that, guys. You know what, Shazam? I have my calculator right here, guys. Let me stop being lazy and throw this on my calculator, everybody. 3 to the 6th power. Ooh, Shazam, boy. I'm so glad I looked this one up. I was like, totally wrong, people. Totally wrong. 729, okay? So yes, guys, every once in a while, they may ask you to actually produce an exact value. Okay, one more, guys, I am going to do, and then I am going to move on to the next rule. And for this one right here, I have 45 x to the 7th divided by, let's see here, 5x to the 3rd. So on this one, guys, you want to go ahead and keep, well, first, let's divide 45 by 5. That's going to give us 9. And then keep the base x. And you want to go ahead and subtract the powers on the x's. 7 take away 3 leaves you with 4. So this would be your answer. Okay, so that's the quotient rule, guys. Now, next, we're going to the power rule, zero power rule, zero exponent rule, that says that anything raised to 0 power is equivalent to 1. Anything raised to 0 power is equivalent to 1. So, for example, if you were to have xy squared to the 0 power, notice it's enclosed inside a set of parentheses, it's being raised to the 0 power, that would be equivalent to 1. However, if you were to have 4 times y to the 0 power, in this case, only the y is being raised to the 0 power, so you would keep the 4 and the y to the 0 would become 1, so the answer for this would be 4. I know, guys. Yeah, be careful with that. Okay, next, rule number 4, guys. Rule number 4 is the negative exponent rule. And for the negative exponent rule, why am I putting an X on here? For the negative exponent rule, guys, it says this. If you have a to the negative m power, this would become 1 over a to the m power. So in other words, you take the reciprocal, change that exponent to a positive. What I like telling students is this. Whenever you encounter these negative exponents, think of a fraction. Think of a fraction, okay? Negative exponents indicate a fraction, guys, okay? So no negative exponents as part of your answer. So when you do these problems, guys, never leave a negative exponent as part of the answer. Get rid of those negative exponents, okay? So let me quickly run through some examples with you guys on this one. So on this one right here, if I have x to the 6th times x to the negative 7th power, so I would keep the base x and add the powers together. And when I add them together, I get a negative 1. So here, this, because it's being raised to a negative exponent, guys, you want to go ahead, get rid of that negative exponent by taking the reciprocal of it. And since it's being raised to the negative 1 power, remember, you don't have to keep that power of 1. You get rid of it, okay? So here comes a second example. Now, for the second example, we've got 10 to the negative 2 power, and 10 to the negative 2 power is the same thing as 1 over 10 squared. And if you can simplify it, you must simplify it. So this becomes 1 over 100. So 1/100th. All right, last but not least on this one, if we had to simplify x to the 2nd, y to the negative 2 power. Now, be careful with this one, guys. They just want us to get rid of that negative exponent. And how do we get rid of the negative exponent? We're going to have to take its reciprocal. So when you take its reciprocal, it's going to become 1 over y to the 2nd. So now you just multiply this together. So you end up with x squared over y to the second. Now, if you wanted to, you could put the x squared over 1 so it makes more sense. But the whole purpose of this problem was to go ahead and get rid of that negative exponent on the y. So guys, and that's it for that one. And then last but not least, rule number 5. Now, rule number 5, this is where we have the power rules. This is where you have a power within a power. So these, I like to tell students to go ahead and use the distributive property. Use the distributive property. Use the distributive property. So to eliminate the parentheses. So what in the world am I talking about? Here's what I'm talking about, guys. So I'm breaking this up into parts for you. Let's say you have a to the m raised to the n power. You see how you have power inside the parentheses, a power on the outside of parentheses. You want to take those two powers and multiply them together. So in other words, you're going to distribute them. So you get a to the m times n power. Here, let me give you a precise example. Let's say you have 3 to the second raised to the 4th power. We keep the base 3 and multiply the two powers together. So you get 3 to the 8th power. That's what I'm talking about, okay? So here comes another one, guys. This time, let's do a times b to the n power. This one, remember, every base has an exponent. So what you do is you take the power on the outside, distribute it, multiply it by each of the powers inside to get a to the n power times b to the n power. Now, obviously, I'm sure you want an example of this. So let me go ahead and clear it out so I can give you a precise example of this. So let's say you have 3x to the second raised to the 4th power. Okay, the 3 has a power of 1. So you want to take this 4 and multiply it by each of the powers inside the parentheses. So you get 3 to the 4th power and then x to the 8th power, because 4 times 2 is 8. So now this is what your answer would look like. But guys, it wouldn't hurt if you were to take the 3 to the 4th and simplify that, which would give you 81 x to the 4th power. I mean, x to the 8th power. So this is more acceptable. Okay, I wouldn't leave it like this. I would write down the answer as 81 x to the 8th power. So guys, the last one I want to look at with you is the one containing a fraction, a over b to the m power. So once again, every base inside the parentheses has an exponent. So you want to take the exponent on the outside, multiplied by each of the exponents on the inside. So this would become a to the m over b to the m. So a quick example of this might be something like this, where you have 2 over x to the 3rd, and all of this is being raised to the 4th power. Remember, the 2 has an exponent of 1, so if you distribute the power, you get 2 to the 4th over x to the 12th. 4 times 3 is 12. Now, just like before with the 3 to the 4th, I would go ahead and simplify the 2 to the 4th. 2 to the 4th is 2 multiplied by itself 4 times, or you could drop it on the calculator to get 16 over x to the 12th power. And that's it. Now, guys, it's a lot of steps and lots of properties, rules to remember, but it is possible for you to be able to do it. So right now, I am going to transition over to scientific notation, where we are going to apply some of these rules of exponents, okay? For scientific notation, this is where you're writing extremely large or very small numbers and multiples of base 10. This is where you write very large or very small numbers and multiples of base 10. When you write scientific notation, it's typically written in the form of a times 10 to the nth power, okay? Now, the a value here is a digit that is less than 10, but greater than or equal to 1. In other words, guys, this needs to be 1. When you write scientific notation, the a value must be 1, non-zero digit, a non-zero digit in front of the decimal. And so make sure, guys, when you're writing that scientific notation, you only have 1 non-zero digit in front of the decimal. So in other words, that number needs to be in between 1 and 10. Now, the exponent, guys, let's talk about the exponent. Now, the exponent is positive if the number is larger than 10 or the decimal, remember every one of these numbers, they have a decimal, is moved to the left. So if you move the decimal to the left or the number is greater than 10, then you're going to end up with a positive exponent. However, if your exponent, okay, if the number is less than 1 or the decimal is moved to the right, decimal is moved to the right, then you'll have a negative exponent. So once again, if you move the decimal to the right or the number is less than 1, then your exponent is going to be a negative. So guys, be careful when writing scientific notation. Now I'm going to run through a few examples with you guys, and then I'll go ahead and leave it there. Of course, we're going to be looking at some additional problems in class as examples. So here's the first example problem, guys. Let's say you are given this number right here. A while ago, I think maybe this was like 2015 or something like this. The national debt was at $18.7 trillion, okay? And let's say they asked you to express this in interval, I mean, not interval, Shazam, interval notation, in scientific notation. So to write this in scientific notation, you would have to first find the decimal and then move the decimal, guys. You keep moving the decimal until you get 1 non-zero digit in front of that decimal, okay, right there. So once you get there, you stop, and then you write down that value that is in between 1 and 10 times 10 raised to however many digits you had to skip over to get to that 1 non-zero digit in front of decimal. So that would be 3, 6, 9, 12, 13 digits. So this would be the number in scientific notation, guys. Yeah. Okay. Right now, the US population is currently at 330 million individuals. So if we wanted to express this in scientific notation, we take decimal from here and move it over until we get 1 non-zero digit in front of decimal. So this would be 3.3 times 10 to the 368th power. So that's the population, US population, in scientific notation, guys. Now, this next one right here, I have 0.00035 I need to write in scientific notation. So in this case right here, because the number is less than 1, I'm going to take the decimal, move it to the right. 1, 2, 3, 4 places to the right until I get that 1 non-zero digit in front of decimal. And because it's less than 1, additionally, because I'm moving the decimal to the right, the exponent is going to be a negative. So be careful, guys. Okay, now we can also do operations within scientific notation. So here comes the next one. Let's say you have 5 times 10 to the 11th power multiplied by 2.9 times 10 to the negative third power. That's multiplication right here, guys. So to multiply here, you want to take, excuse me, the 5 times 2.9, 5 times 2.9. Go ahead and type it into your calculator, 5 times 2.9. And once you figure out that value, then you're going to go ahead and keep the base, okay? Keep the base 10. And because you're multiplying with the same base, what you do is you keep the base, add the powers together. So negative 11 plus 3 is going to give you 8. Now, guys, it looks like this is correctly written in scientific notation, but it's not correctly written in scientific notation because, guys, you have 2 numbers in front of the decimal. So you got to take the decimal from here, move it over 1 more place to the left, which is going to increase the power by 1. So the correct answer would be 1.45 times 10 to the 9th power. Now you're done, okay? I'm going to do one more, and then I'll be done. Number 5, everybody, it's 1.8 times 10 to the 15th power over 2 times 10 to the negative 3 power. So on this one right here, we're going to take, because it's division, we're going to take the 1.8 divided by 2. 1.8 divided by 2 leaves you with 0.9. Keep the base 10 and subtract the powers, okay? Keep the base 10 and subtract the powers. 15 minus negative 3. So this turns out to be 0.9 times 10 to the 18th power. And then you have to ask the question, is this correctly written in scientific notation? What you will notice, guys, is that you do not have a non-zero digit in front of the decimal. You actually have a 0 in front of the decimal. So no, this is not correctly written in scientific notation. So you have to rewrite this correctly in scientific notation by taking the decimal from here and moving it over 1 more place to the right, which is going to decrease the power by 1. So this becomes 9 times 10 to the 17th power. That's correctly written in scientific notation. And just like that, guys, we are done. We'll do some additional examples in class. So until next time, bye, everybody.